Going on, apes? Welcome to another lecture. This one, we're looking at the heavy metals and how they end up in our water supply, and then how toxic they are, even in small quantities, to organisms and especially humans. So, there are heavy metals. They're these groups of chemicals that can pose these serious threats to humans and other organisms. So, we're going to focus on three heavy metals that are particular concern in environmental science, and that is lead, arsenic, and mercury. So starting with lead, we rarely find lead in natural sources of drinking water, but it can contaminate when we this water is passed through lead pipes. So lead pipes used to bring water to homes. So you can see in the diagram that it's clean water leaving the plant, but by the time it goes through these older pipes that contain lead, and they might not even be the pipes, it might be the brass fittings or even the solder when they connect two pipes that could contain the lead. So the lead is transported through the pipes to the home, and that's how the people ingest it. And it's highly toxic, especially to children and fetuses. So, and even the elderly. So, what can happen with lead poisoning is it can cause damage to the brain, especially the central nervous system, and even the kidneys. So, what's been going on is federal guidelines, once we've realized this, is now any homes, this has been going on for the past 30 years, any homes um, can no longer have these lead pipes bringing water to their homes. So it's still a concern in older neighborhoods where these homes were built prior to the mid 1970s, where lead could still be a concern. And as you all, I'm sure, are aware of, this is happening, still continuing happening in Flint, Michigan, where if you click the picture, if you're on the Google slide, it'll give you a timeline of what started to happen. And essentially what was going on is the city of Flint was trying to save money by diverting their water from Detroit, going off the Detroit water and onto a new system. But unfortunately, that just took lead to all the homes in that area. And that's a crisis that's still going on as of February 2018. Moving on to arsenic. Arsenic it's naturally occurring in Earth's crust, so in the rocks. And what can happen is through the process of, rain and the water leaching through the crust, it can end up in the groundwater. And even human activities will contribute to higher concentrations. And a lot of these human activities are mostly due to mining and industry as well. So any wood that is treated, to prevent it from water damage, things like that, arsenic is used there. So this gives you a great overview of the kind of everything you need to know of where it's coming from, how the symptoms of arsenic poisoning, what is considered safe in regards to the EPA, and then exposure throughout the world. And you can see most exposures are occurring in Asia, where they have high concentrations of arsenic in the water and even in their food due to their reliance on rice crops. So arsenic, of the three we're talking about today, is the easier to remove from a water system. You can do a few things. You can have a membrane that just filters it out. You can distill it, or then even reverse osmosis to remove that arsenic. And something interesting here, by looking at the map, you can see the higher concentrations of arsenic are the darker colors, and you can see the East Coast doesn't have that much compared to as we start to move west. And the reason for that is, remember, arsenic is found naturally in Earth's crust, so there's a lot more mining operations from on the West Coast, which is why we see this high concentration. So how do we move arsenic? So when we have it in the drinking water, the problem is it causes cancer to the skin, lungs, kidneys, and bladder. And the unfortunate thing is you can be exposed and not have these illnesses develop till much later. So it could be 10 years after you ingest this arsenic, or you've lived in a home where water contained the arsenic, and it's not till 10 years later that you see these symptoms. The other scary thing about arsenic is it does not take a lot to make someone ill. You can develop cancers with less than 50 parts per billion in your drinking water, and for a while, 50 parts per billion was considered safe by the EPA. And this changed rapidly in 1999 when they started to do research and they realized this is way too high concentration. So the EPA did studies, and now today 10 parts per billion is the standard. Anything over is considered unsafe for consumption. Moving on to our last heavy metal, and that's mercury. Mercury, the biggest thing here is it's produced by humans, mostly by the burning of coal. And you can see in the pie chart here, Asia is the largest contributor of mercury, just because of the still high reliance on burning of fossil fuels, especially coal in those countries. So other sources, though, it's not just the burning of coal. When you burn garbage or any hazardous waste, your medical and dental supplies, and even raw materials found in cement, when they're making cement and what's necessary to build the cement, the sources of mercury come from those raw materials that go into the manufacturing. So the limestone used to make the cement can contain mercury, and this mercury is then released during the heating process that is needed when making the cement. So again, there's not just one source of the mercury that's in our environment. And then finally, petroleum exploration. So this is a source of both mercury and lead pollution. And each petroleum well produces about 180,000 gallons of contaminated waste, water, and mud in its lifetime. And there's a ton of petroleum exploration going off the coast of in the Gulf of Mexico and even on the West Coast. So that just gives you an idea of where where this mercury is coming from. The other interesting thing about mercury is that it's in its inorganic form, it's not harmful. So as the mercury you're familiar with in your chemistry class, the mercury given off by the coal plants isn't essentially harmful until it is created and until methyl mercury is created. What's happening there is methyl mercury, so that mercury ends up in bodies of water, either through deposition from rain after it's up in the atmosphere, or it flows from a river to the ocean. And what happens is this bacteria will start to break it down, and unfortunately, as a result, will create this methyl mercury, which is highly toxic, and it damages the central nervous system. And by looking at this, you can see that particularly young children and the developing embryos of pregnant women are a concern, and the results kind of impair coordination, senses of touch, sight, and it affects you can see in this figure different parts of the body. So something to consider is even some of the cosmetic soaps, things we're putting on our body, contain this mercury in it. The main exposure to mercury in humans is through eating fish and shellfish. I'm sure you've heard this before. It's a term you're going to hear again, but biomagnification. So all that's happening is you have this methyl mercury. There's not a lot of it in the water, but unfortunately it goes up the food chain. And by the time it goes up to these predatory fish like shark or halibut, the concentration of mercury is so high that some of these fish are not fit for consumption, because when you eat them, then you have this high concentration of mercury in your body. So again, to give you an idea, it's the predatory fish. It's again because it's going up that food chain. There's might not be a ton, let's say, in catfish, but then as the catfish is eaten by the carp and moves up again, you have these high concentrations, which again will affect humans. Always like to end on a happy note, but unfortunately, there's this study that in 2008, and again, if you click this link, you can read more about it. But what happened is the New York Times purchased tuna sushi from about 20 locations in New York City. And after analyzing, they took it to a private lab. They found that at most restaurants, a diet of six pieces of sushi per week would exceed the EPA standard for human consumption of mercury. So, I mean, 6 pieces of sushi is more than enough mercury for you to consume. So, something to consider. And in 2009, the EPA even reported that concentration of mercury in tuna in the North Pacific increased by 30%. And it's believed that that is going to increase by another 50% by 2050. So, it leads to the question, what can be done to mercury in regards to mercury pollution? So, in 2013, it's good to note the U.S. announced a new agreement with more than 140 countries to reduce global mercury pollution. And in a step towards this goal, the EPA proposed that cement manufacturing plants reduce mercury emissions by 92% as well. And even now, as years and days go on, new EPA rules are also being written to reduce the mercury emissions from other major sources like the coal power plants. So that wraps up our lecture on heavy metals in the water. As always, if you need anything, shoot me an email, come see me, or check out the lecture again on the website.